Today, we're going to talk about marine dynamics. The ocean makes up 97% of Earth's water and covers 71% of Earth's surface. Most ocean biodiversity is found in shallow waters close to the continents, and 91% of marine species still await description. The major factors shaping ocean life are temperature, circulation and currents, nutrients and primary productivity, and abiotic factors such as light, depth, density, salinity, and pressure. So, what is the Coriolis effect? The Coriolis effect is caused by the Earth's rotation. It causes objects north of the equator to be deflected to the right and objects south of the equator to be deflected to the left. This affects ocean currents and wind. Ocean current and wind caused by the Coriolis effect will cause upwelling and downwelling. Upwelling pulls up pockets of colder water and higher nutrient waters from below, and downwelling pulls down pockets of warm surface water and nutrients to the deep sea.
Upwelling serves as a vital nutrient source for phytoplankton. Greater nutrients for them means more oxygen and available food for larger zooplankton, who in turn become food for small fish and invertebrates, who become food for large fish and mammals. Upwelling zones globally are some of the most productive areas in the oceans. However, a balance of nutrient input is key. Eutrophication, or excess nutrient input, can cause too many phytoplankton to bloom, and they end up depleting the water of oxygen, making it uninhabitable for other organisms. Surface nutrients also serve an important role in the global carbon cycle. As detritus, or dead organic matter, falls from the surface waters, it serves as an important source of food for the organisms in these deep and dark waters where photosynthesis isn't possible. This phenomenon of marine snow pulls carbon down from the surface and stores it in the deep. Depth is also an important physical factor that has a lot of influence on other abiotic attributes of the water column. For example, light decreases with depth, typically extending to about 200 to 250 meters, thus putting a limit on photosynthesis.
So let's talk about the ocean zone. We're mainly focused on four parts: the Nearctic zone, the littoral zone, the pelagic zone, and the aphotic zone. So firstly, the natural zone is the shallow water along the coast. The depth is 0 to 200 meters and it's rich in species. The interaction of land and sea, like this kind of wave action, will bring nutrients. And then the littoral zone is part of the Nearctic zone. The depth is 0 to 100 meters and the organisms there have large variation to adapt exposure. Habitats are differentiated by the substrate. The pelagic zone is open water and it includes photic zone and aphotic zone. The photic zone is 0 to 250 meters and provides light for phytoplankton, and aphotic zone is over 250 meters. The aphotic zone includes the seafloor, is the deep sea and rich in biodiversity, and there have the thermal vent communities. That's all. Thank you.